Okay, thanks. Shall we continue? Yes, this is one of the sample question as well. Okay. 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 Now, this is from SPS's output data. Okay. As you can see, this SPS's output data. Okay. Okay, guys. This is a SPSS output data, guys. Okay. Can you hear me, guys? Do you follow? Hello. Okay. Cool. So you just do some analysis using a SPSS, and this is the output you appeared on the screen. All right, this is the list of that output in there. All right. So the variable is listed down, and okay, whenever you see the one there, that means this is a dependent variable. That means y. Okay, and the rest will be our independent variables. It could be x1, x2, x3, and so on. Okay. So career development, compensation and rewards, job security, working environment, supervisor support. Okay, these are the elements we called as I we called as is a independent variables. Okay, independent variables. So now we would like to know that the data. All right, we're going to analyze the data. So what is that? The conclusions based on the data you'll be able to deduce. You need to analyze the data. You need to give a explanation for each every data. So what the information you can collect it. Okay, by looking at each every terms. Okay, based on this data, you need to come up with your own conclusions. All right, you can say that. Look at that the Pearson correlation. The Pearson correlation is this is pretty much is like closing to see the Pearson correlation. You know correlation coefficient. The Pearson correlation coefficient. Oops. Correlation coefficient. Okay, the correlation coefficient, we claim that is has to be between -1 less than r less than the r is correlation coefficient formula, the symbol, and to 1. So whatever they close to 1, they call a strong linear positive, and whatever close to the -1, we call close negative linear relationship. And whatever in the 0, all right. So this is your range. Okay, this is 1, this minus 1, and this is 0. Okay. Mm, okay, this 1. Okay. So whatever they close to, the figures close to 1, they call a strong linear positive. Whatever closer to minus 1, they call strong negative linear relationship. And if it is closer to 0, then we call is no relationship. Okay. All right. As you can see here, in the data, the Pearson correlation is showing is all everything closer to 1. Okay, this is 0.865, this is 0.869, 0.96909, this is 0.846, this is 0.9. So this is all closer to strong positive relationship. Okay, they're all closer to strong positive relationship. So you can say that. So the variables, the independent variables are what? All are strongly related to the employee satisfaction. So this is all that strongly supported or strongly related. So you can say that this, as I said, this independent variable x1. Okay. Moving. Okay. So this is your y, this is your x, x1, x2, x3, x4, x5, and so on. So this is your independent variable, and this is your dependent variable. Employee satisfaction is the dependent variable. So you can claim that since all this value, all right, closer to 1, so you can say that this, okay, you can see that the independent variable has a strong linear relationship to that employee satisfaction. Okay, so you can say that they are all the independent variables are strongly closer or related to the employee satisfaction. Okay, so that's the answer. And then another information, you can say that, look at that, all that point is 0.000. That means, what does it mean? So 0.0 is closer to 0. Is closer to 0.111, so means 0.05 less than 0.05. So that means this is all closer to 1%. So you can say that this is closer to, or you can say that is a closer to or significant to at 1%. Okay, 1%. So this is closer to 1%. Okay, and so on. All right, so this is your the first questions. Okay, so I'm going to clear this the writing. Do you copy that, guys? Please let me know if you want to copy. Okay, cool, thanks. All right, we just move to the question B. All right, so how are you going to deduce this? How are you going to interpret this data? Can you tell me? Your r square is will be given. Okay, r square, we know that r square is there. Okay, r square, the r square already given is 0.892. Okay, so what you can conclude with this? Model 1 r is given 0.945. This is your r value and r square value, and this is the adjusted r square value. So how do you get r square? You just take this value and then you square, you get is 0.892. Or you can use a calculator. You can say 0.945, you square, and you get a 0.89, they round up to 3. So just 2, 0.892. Okay, how can I do that? So you can say that, this is a change in the percentage. So your 89.2 percentage, okay, of the variation, okay, of variation can be explained okay, variation guys, variation, I mean the changes that means r square 89.2 percentage of the variation can be explained by independent variable, by independent variable. Okay, so what information you can collect? What else? Okay, good. So you can say that the balance, how much? Is not discussed. It's 10.8, right? Okay, just find the balance of it. Okay, so 100 minus with the 89.2, the balance will be variation is not discussed. Okay, correct. So you can say that okay, I think letting is already written in that in the group. So yeah, correct. Okay, now look at that the C ANOVA test. Okay, so take a look at the ANOVA test. Okay, you are given right. Um, like clear this part. Okay, you are given regressions values. Sum of square is a 285.961 and residual is 34.467, and then total is 320. You just add up everything. And then the degree of freedom is 5 and residual is 214, and the mean square is given 57.192, and the mean square for residual is 0.110, and the f value is for the regression is 5 to 1. That is quite big. Okay, it's good. And significant is approaching 0.0054, closer to 1. Okay, now say how are you going to deduce this output? Is a straightforward. From this data we know only we look at that the f value is very good. Okay, so you can say that the significant value is smaller than 1. Okay, is a very good. It just you can find the significant value is smaller than 1, so smaller than 1%. Okay, so therefore the model, okay, the model can be, because we're talking about the regression, right? So what should be the model represent to? And we're talking about the residual as well. So we can say that the model is actually is a least square regression line. Okay, least square regression line. Or you can say that another way you can see that as the model is a least square. You can put it this way. Uh, the least square regression line at the good fit. Okay, and you can say at good fit. Or you can say that some books they refer to the model can be used, or the model can be appropriate to use as a good fit. Okay, so there's many ways you can deduce this type problems. Okay, all done. So next, we just move to the next part. Okay, we clear this before that. Okay, do you copy this? Okay, I hope we copy. So we clear this first. Okay, now take a look at question B. All right, so based on the table, the SPSS output, you need to answer the following questions. Okay, now, all right. So now we need to deduce the table. All right. So from here, we know that the table. Okay. So what we can do that? First, we need to look at that. Okay, don't look at this constant. You don't have to look at the constants. Look at the independent variables. Okay. So look at that all that the significant variable is just nice. It's less than 0.05. So that is significant. Okay, it's significant. Okay, so you can say that the first is all that the variables or all the independent variables are significant at 1%. Okay, so you can say that the first all the variables or independent variables significant at 1%. Okay. Okay. Next, look at that the unstandardized and standardized coefficients. Okay. Uh, we look at that the standard error. Okay, or error estimation. Okay, error estimation, standard error. Okay, and then okay, beta value is only this is a coefficient value, guys. Coefficient value for this your variables. Okay, you can see that your unstandardized coefficient values. Okay, so called okay. So look at that each and every variable. So first you can see by looking at your coefficient values. Okay. So your okay. Say this is your dependent variable. We look at the higher contribution, the high contribution of the figures. Look at this, each every component. Which one the constants values are highly contributed. This is 0.286, 0.165, and JS is a 0.289, WE is a 0.146, and SS is a 0.146. So as you can see, this is your JS the higher contributor. So you can say that the second data, the information you collect from this, the unstandardized coefficients, the highest contributors to this model. Okay, the highest contributor or influential is JS. Okay, so it's 0.29 to 0.289. So 0.289. So this is high contributors. The lowest contributors you can say as you can say that these two. All right, this is less than 0.146 and 0.147. So this considers the two are lower. Okay. We can take that VE, but it's better to take both together because it's closer one to mine. And this is all a median. All right, this is all median. All right. We don't consider anything about constant, guys. Remember, nothing can do anything with the constant. Just leave it as it is. Okay. The highest is JS, and the lowest is the WE and SS. That's the information you can given by from this table. Okay, state the model of the table in D. All right. Okay, you need to state the model. Okay, how are you going to model? Say you're going to create the model. Say your this data is Y. Okay. So how are you going to write the data? First is come up with a constant, right? Remember your beta value, beta naught, beta 1, x1, beta 2, x2, beta 3, x3, and so on, right? Okay, so you just write that this y equal to, first you need to write minus 0.049, see this, minus 0.049. Okay, that's your first thing. So you can say that. Just look for the right space here so that I can write that example. Okay. So, all right. So you can write the model as y equal to minus 0.049 plus, okay, your next model is CD. So you can say that as 0.286 CD plus, now the CD all is the X2, guys. Remember, this beta 2, oh sorry, beta 1 is, beta naught is a constant, beta 1 is 0.286, and X1 is we replace with CD because based on the given variables. So beta 3 will be CR, so that will be 0.165. So that will be CR, and plus so on. You just fill the rest. Okay? Is that clear? Guys, is that clear? I think we are run out of time, so okay. Okay, let me quickly just cover the question. If you just shut down, please, you just reconnect the same ID, okay? So we just write what? Yeah, because you already given the beta value. So just times with that the all the variables. Okay. Okay, guys, look at this question F. It's they wanted to provide some overall comments based on the result obtained. Okay. So what is the overall comments you can give based on that this result, the tables? Okay, you see, look at that. They just simplify for that, yeah. So you can use this the short form ES CD CDA R JS VWE and SS. Okay, you can use this short forms. Okay, so